Today I'm going to demonstrate how you can maintain our Spira-trol control valve without removing the valve body from the line. In the video we will cover in detail how you can remove the positioner, remove the pneumatic actuator, then maintain the internals of the valve body, reinstall the actuator, reinstall the positioner, and then commission the valve so everything is up and running and ready to go. When we talk about a control valve, we're referring to the valve body, the actuator and the positioner. The positioner has several roles. It can be an amplifier, it can be a converter from electric to a pneumatic signal, and more advanced positioners have functions that allow you to fine-tune your process. The actuator is what provides your motive force to move the valve into the position it is needed to control your process. So to remove the positioner from the control valve, we first need to disconnect the air supply and turn off the control signal. And you'll see the positioner has now lost its power. Using a flathead screwdriver, we can then open the positioner. Depending on the model of positioner you have, you may need to use a hex key for this part. We can now use a smaller flathead screwdriver to disconnect the electrical control signal connections, and we can disconnect the cable gland from the side of the positioner and remove the cables. With the compressed air supply isolated and the control signal wires removed, we can start to remove the compressed air piping. With the compressed air and control signals disconnected from the positioner, we can now remove it from the actuator. We will need to use a 13mm spanner to loosen and remove this bolt. We can now use a flathead screwdriver to loosen and remove the screws holding on the magnetic bracket. To remove the actuator, we need to reconnect the air supply to the actuator so we can move its position. We then need to apply enough air pressure to move the actuator to its mid-travel position, and we can do that by looking at the spring range of the actuator. For this actuator, the spring range is 2 to 4 bar, so if we apply 3 bar of compressed air, that will take the actuator to its middle position. With the actuator in its mid-travel position, we now need to remove the clamp here, and to do that we need to use a hex key and an 8mm spanner. With the clamp removed, we can now access the valve adapter and locking nut using a 16mm spanner on the valve adapter and a 13mm spanner on the locking nut. We can loosen the locking nut and wind it away from the valve adapter. We can now wind the valve adapter down away from the actuator coupling piece. Next we need to remove the actuator clamping nut, and to do this we need to use a 41mm claw ring spanner. Once we've loosened the clamping nut, we can remove it from the thread and remove it from the actuator. Next, we need to reduce and isolate the compressed air supply. Hold on to the actuator at this point because it will move up a little bit, as you can see. Once the compressed air supply is isolated, we can remove the actuator from the valve. Before we remove the bonnet from the valve, it's a good opportunity to loosen the gland nut, and we take a 30mm spanner to do this. We don't need to remove it, we just need to loosen that for later on. To remove the bonnet itself, we need to undo the 4 nuts. These are all 19mm. We can now remove the bonnet. We can take the bonnet to a workshop to change the stem seals. The real benefit of the Spira-trol valve design is we don't need to remove the valve from the pipework. We can replace the internals of the valve while the valve is still in line. We can remove the cage and then remove the seat. Next, we need to remove the gaskets. There are 2 gaskets. There is one inside the bonnet underneath the seat, and there is one on top. If the valve's been in service for quite some time, these can be quite tricky to remove. A scribe tool is particularly useful. You can use the tool to scribe around under the gasket until it comes loose and is able to be removed. At all times, we need to be careful not to damage the valve body with any tools that you are using, because this can cause a leakage path once the valve has been reassembled. So once the gaskets have been loosened, we can remove the seat gasket from inside the body, and the bonnet gasket here. We may need to use a gasket scraper to remove any residual graphite from the sealing faces, and then we can use a wire brush to just remove any loose graphite so that we leave a nice clean sealing face for the new gaskets. Check the condition of the new gaskets before you install them. We can place the seat gasket inside the body and the bonnet gasket into the bonnet area. Again, the same for the new seat. Check the condition and we can put that in place. Finally, we can pop the existing cage back into the valve body. Make sure that the holes of the cage are aligned with the flow of the valve. We need to remove the valve adapter and lock nut. Then we can remove the gland nut, which we loosened earlier, and the valve plug and stem. Now we can remove the stem sealing from inside the bonnet. To do this, we can use a scraper tool. We can start removing the top pieces of the stem sealing from this end of the bonnet, and we may need to turn the bonnet round and push some of the lower pieces out from this side. We also need to remove the scraper ring from the gland nut. When using the scraper tool, we need to be careful not to damage any of the internal surfaces of the bonnet, as that will affect the sealing of the new stem seal kit. With all of the old stem seal components removed from the body, we can now insert the new stem seal kit. Before we insert them, just check the condition to make sure there's no damaged pieces, and we insert them into the bonnet this way up, and we are then able to simply remove the plastic retaining part. Push the stem sealing as far into the bonnet as possible. You may need to use the gland nut and a plastic mallet to tap the stem sealing down until you are able to locate the gland nut onto the threads inside the bonnet. Once you're able to do that, you can then insert the scraper ring into the gland nut. Finally, we can insert the new plug into the bonnet before taking it back to the valve. As before, just check the condition of the new parts, especially around the sealing face here, for any damage or scratches. And we can now insert that back into the bonnet. Put the valve adapter back onto the stem, and we wind this down until 2 of the internal threads of the valve adapter are remaining. Once that is in position, we can tighten the lock nut to secure it in place. We will need a 13mm spanner for the lock nut and a 16mm spanner for the valve adapter. We can now put the bonnet back onto the valve. Before we do so, we must push the plug into the bonnet, but ensuring that the threads do not go any further than the gland nut. We can now put the bonnet onto the valve, ensuring we push down on the plug at all times. This will stop the plug from moving against the seat and causing any damage to the sealing surfaces of the new plug or the new seat. We can now put back the nuts and hand tighten them, and we must follow the sequence shown in the installation manual to ensure a constant pressure is pushed onto the plug and to the seat. We must now pull the plug up and push it back down into the seat. What this does is this makes sure that the plug and seat are well aligned. As we saw earlier when assembling the valve, the seat is held in place by the cage, and the cage is pushed onto the seat by the bonnet. So until it is fully tightened, there is still some movement allowed in the seat area. So by pushing down the plug in this routine, we are constantly realigning the seat and plug every time we tighten the nuts. If this is not done correctly, we can have issues with valve leakage and increased wear. So again, we hand tighten the nuts following the sequence given. We pull up the plug and we push it back down. Every time we do this, we're listening for a nice, clear, clean metal to metal contact sound. If we don't get that clean sound and it's more of a dull thud, then it's likely that there is either debris in between the plug and the seat, or the plug and the seat are misaligned. If that is the case, we can loosen the nuts, remove the bonnet, check for any debris and start the process again. So after doing this twice with hand tightening the nuts, we can use a 19mm spanner and turn the nuts 45 degrees, again following the sequence. And again, we want to listen out for that nice clean contact. We can do that several more times, at 45 degrees each time, until we are happy that we've got an even tension on all of the nuts. Again, pushing and pulling the plug every time. We then need to start the process of tightening the nuts up with a torque wrench, and we need to do this in several steps also. So first of all, we go through the same routine at 10% of the required torque. Pull the plug, push it down, again listening for a clean contact, and then we repeat the steps at 40% of the required torque, 60%, 80%, and finally 100%. The torque will depend on the valve size, and this information is given in the installation manual. Once you have tightened the bonnet nuts to 100% of the required torque, just to ensure we have good alignment between the plug and the seat once more, we lift the plug and we turn it 120 degrees and we push back down. And we lift the plug, we turn it 120 degrees, we push back down. And we do that 3 times to ensure that we have good alignment for the full area of the plug and the seat. Once that is done, we can take a 30mm spanner and we can tighten the gland nut until we get metal to metal contact between the top of the bonnet and the bottom of the gland nut. We can now relocate the actuator, and we will need to increase the air pressure again to the mid-travel position, which for this actuator is 3 bar, and that lowers the actuator into position. With the actuator in position, we can now hand tighten the actuator clamp nut. With the actuator clamp nut hand tightened, we need to reduce the compressed air supply to the minimum spring range of the actuator, which in this case is 2 bar plus 0.1 bar. We then may need to adjust the actuator connector so it touches the valve adapter. As this is the actuator we removed before, it's already in the correct position. We can now reduce the actuator supply pressure back to 0 and refit the clamp. Again, we need to use the 8mm spanner and hex key, and we need to tighten each side of the clamp a little bit at a time. With the actuator clamp in place, we can now refit the positioner magnet, and we can use a flathead screwdriver to tighten the screws. And just be sure that the screws are in line with the actuator marking for the actuator that we're using. So with the compressed air supply still connected to the actuator, we need to move the actuator to 50% travel. As we established earlier, this is a 2 to 4 bar actuator, so if we increase the air supply to 3 bar, that will move the actuator to 50% of its travel. We're now ready to reattach the positioner. So if we hand tighten the 13mm bolt, that still allows us to move the positioner up and down. We need to have the cross on the back of the positioner aligned with the magnet that we attached to the actuator before. Once those two are aligned, we can use 13mm spanner or socket to tighten the positioner so it's fixed in place. We now need to vent the air from the actuator. Once the air is vented, we can disconnect the air supply from the actuator and reconnect that to the positioner supply port. And we connect the air from the output port of the positioner into the actuator. We can now reapply the air pressure, and because this is a 2 to 4 bar actuator, we need to apply roughly 5 bar air to the positioner. We can now open the positioner to access the controls for the auto commissioning routine. So we can see by applying a control signal to positioner, it is now powered on, and to run the positioner through the auto stroke Routine, we simply need to press down the enter button for 6 seconds. And we can see the positioner is now going through the auto stroke routine. If the auto stroke routine is successful, you will see a small smiley face appear in the bottom left hand corner, and the positioner screen will go back to a live mode and display the percentage of travel. And we can see that change by changing the control signal into the positioner. Alternatively, if you want to see the control signal going into the positioner, press the enter key once and it will display the number of milliamps. Press the enter key to go back to percentage travel. The positioner is now commissioned, so we can reclose the cover and restart our system.